tangential acceleration. This is the acceleration due to center of mass at the point of contact I am talking. Due to rotation, this wheel is rotating like this, means like this. Okay, wheel is rotating. So in this direction, this point of contact will try to go up like this. So due to this, due to rotation, there will be the tangential acceleration, that will be r alpha. So at the point of contact, there are 3 acceleration. 1 acceleration more will be there. This acceleration is due to the center of mass. This acceleration is due to the rotation like this. Now there will be 1 more acceleration. This point P is rotating in a circle also. So due to that, there will be a centripetal acceleration also. And centripetal acceleration is always act towards the center. So there will be the centripetal acceleration. Or you can say radial acceleration. Centripetal, or you can say radial acceleration will be there. Now this is ground, and this ground is at rest. This is ground, and this ground is at rest. Now, in this case, for the condition of the pure rolling, the acceleration of point P with respect to ground should be 0. Acceleration of point P with respect to the ground should be 0 for pure rolling. Acceleration of point P with respect to ground should be 0. What is the net acceleration of point P? So you can write acceleration of point P minus acceleration of ground, that is equal to 0. So what is the acceleration of point P? Acceleration of point P is AC minus R alpha. Acceleration of point P is AC minus R alpha, no? Acceleration of center of mass minus R alpha. So it will be AC minus R alpha. And acceleration of ground we know is 0. Because ground is at rest. So you can write AC is equal to R alpha. So this is the condition for the pure rolling, for the acceleration. Now alpha will be acceleration of center of mass, that is equal and divided by R. So angular acceleration condition will be this. This will be the angular acceleration condition. So this is the condition for pure rolling. Condition for pure rolling. Now can you tell me, Hiva, at this point, during the pure rolling, what is the acceleration at this point?
0.
No. I know that you will say 0. Now you can see tangential acceleration is 0, na? AC minus R alpha is 0, means this acceleration is 0, but there is one more acceleration here, centripetal acceleration. So during the pure rolling, always remember the acceleration of point of contact is not 0. It is equal to the centripetal acceleration. So in pure rolling, the net acceleration of point of contact is radial acceleration or centripetal acceleration. AC means, okay, centripetal we will not represent with AC. Okay, we should represent this with AR. Radial acceleration. Why? Because AC we have already represented. So AR is what? AR is radial acceleration or tangential or centripetal acceleration. Radial or centripetal acceleration. Okay. Is ER. Okay. So this is a condition for pure rolling in terms of the acceleration. In this case, this ground is at rest, means the platform on which this body is rolling is at rest. Now there can be the another platform. There can be the another platform in which platform is itself moving and the body is rolling on that. So that condition also we'll see. Okay. So remember acceleration of point P with respect to the ground. Acceleration of point of contact with respect to ground. APG means acceleration of point P or point of contact with respect to ground. This can be written as acceleration of point P minus acceleration of ground. Acceleration of ground is 0 because ground is at rest. Rest means no acceleration, no velocity changing. So you will have angular acceleration of the body will be, so this body will have some angular acceleration alpha. So the angular acceleration will be AC by R. AC is the acceleration of center of mass. R is the radius. Now I will take one example in which the platform will also have some acceleration. First write down this, then we will discuss the another case. Hello, Dibyangi. Changi, are you getting my voice?
Done, sir.
Okay. Write down this point also.
Done, sir.
Okay. So now we will see here. We have seen that this body is rolling on the ground. Now we'll see the body will roll on a platform which is moving with some acceleration. So this is rolling on this platform. You can say this is some object. And this have some acceleration A naught. This is the platform. Now this platform is having the acceleration of A naught, and this body means have the acceleration of center of mass AC. Okay. So this is the point of contact. Now we have to find AC. The value of AC we have to find in terms of A naught. In terms of A naught, we have to find the value of AC. In this question, it is given that this body is performing pure rolling. This body is performing the pure rolling. So now we know that in case of the pure rolling, the point of contact, okay, the point of contact should be at rest. At rest means this point of contact at the moment is at rest. Okay, after that this point of this point of the wheel, or this point of this disc, whatever, will go there. In terms of the acceleration, we can say acceleration at the point of contact with respect to the platform should be 0 at the, okay. So we will see at the point of contact. At the point of contact, the first acceleration will be AC in this direction. Another acceleration will be R alpha in this direction. Suppose this is point P. Now what is the acceleration of point P? We have acceleration of point P is AC minus R alpha. AC minus R alpha. Now this platform is moving with an acceleration of A naught. Now for pure rolling, we know that for pure rolling, the acceleration of point P with respect to there, what we have seen, acceleration of point P with respect to the ground. So the body is rolling on the ground. So with respect to the ground, the acceleration should be 0. But now the body is rolling with respect to this platform. Now with respect to this platform, the acceleration of the point of contact should be 0. So this is platform Z. So acceleration of point P with respect to Z must be equal to 0. Now we can write acceleration of point P minus acceleration of Z is equal to 0. And acceleration of platform, Z means platform, is A naught. Acceleration of platform is A naught. So acceleration of point P is what? AC minus R alpha. Net acceleration of point P will be AC minus R alpha. So it will be AC. For AP we can write AC minus R alpha. AZ we can write A naught. That is equal to 0. We can find AC from here. That is equal to R alpha plus A naught. R alpha plus. So you have AC in terms of A naught. That is R alpha plus A naught. So you have to remember, with respect to the platform here, the acceleration of point P will be 0. Because here the acceleration, there will be the acceleration of platform also. Write down. Done. Okay.
Done, sir.
Okay. So now suppose there is a body like this. This is some body, and this body having the velocity v, and a force is applied on this body on the center of mass. F force we are applying on the center of mass, and this surface is a smooth surface, frictionless surface. The surface is frictionless surface. Now, in this case, the force is applied the center of mass. So due to that, and this surface is a smooth surface, means there will be no friction force here at the point of contact. There will be no friction force. So if there will be no friction force, and you are applying the force on the center of mass, so due to this force, there will be no torque. Due to this force, there will be no torque, and there will be no other force also to generate the torque. And for the rotation, there is requirement of torque, means this body will slip and this body will never roll. Okay, so you can write here, no torque created you can see torque is zero with respect to this force. The torque is zero, and there is no other force that is generating the torque, so there is no torque here. So if there is no torque, it implies that the body will never roll. So for rolling, there is a requirement of torque. For rolling, there is requirement of torque. Now we can take another case. This is the case in which this surface is not frictionless surface. This is rough surface. In real life or in practical life, we do not have the smooth surface. We have rough surfaces. So this is rough surface. If this will be a rough surface and you are applying a force on the center of mass, then this you are applying force in this direction. So at the point of contact, so point of contact means this point will have the tendency to go in this direction, to slip in this direction, but friction force will be acted in this direction. Friction force will be acted in this direction. This is the friction force. Okay, you are applying a force in this direction, so at the point of contact, friction force will oppose the relative motion. So this body at this point of contact will have the tendency to go in this direction. So friction force will act in the opposite direction. And R is the radius. R is the radius. Now, due to this force, there will be no torque, but due to this friction force, there will be torque about the center of mass. F into R. There will be torque about the center of mass. Now, torque about the center of mass, that will be friction force multiplied by R. In this means like this, there will be a torque. Just wait. Okay. So there will be a torque, and this torque is in anti-clockwise direction. Anti-clockwise direction. Now we know that due to this torque, there will be the angular acceleration, because torque is equal to I alpha. So there will be the angular acceleration. In this body, there will be the angular acceleration. Now, what is the meaning of angular acceleration? If there will be the angular acceleration is rate of change of angular velocity. Means if there will be acceleration, means angular velocity will increase. Angular velocity will increase. So after some time, now what will happen? The angular velocity will increase. After some time, the angular velocity is increased to such level so that the velocity v at the point of contact will become equal to r omega, and this is the condition of pure rolling. So you can say the body will roll due to the friction force. Start rolling due to friction force. But we know that in rolling, the point of contact will be at rest. In rolling, this point of contact will be at rest. For example, so suppose I am taking a condition that is after some time, okay? After some time, this is the body, and this body have the velocity of center of mass in this direction, and having this body will have the angular velocity omega dash after some time, and having the velocity v dash. So in this direction there will be a velocity v, and in this direction there will be a velocity r omega dash, and in this condition at the point of contact it will be r omega dash. Okay, so this condition will become, and this condition is of pure rolling. This is a condition of after some time. See, from the starting, due to this friction there will be a torque, and due to the, we know that torque is equal to I into alpha, means due to torque there be the angular acceleration, and due to angular acceleration there will be increase in the angular velocity, and after some time the angular velocity will increase to suppose omega dash, and v dash is equal to r omega dash after some time, means the pure rolling will start, means this point of contact will be at rest. Now this point of contact, when the point of contact will be at rest, at that time the friction force automatically will become zero. So basically what is happening, due to the friction this body is coming to the condition of coming to the means performing the pure rolling, and when pure rolling start, friction goes. Now in here there will be no friction at point of contact. Okay, so what is the cause of the rolling here? Friction force is the cause of the rolling. Torque due to the friction force is the cause of the rolling. And in this case, why there is no rolling? Because there is no torque. If there, first what is happening? Friction force, due to this friction force there will be a torque in anti-clockwise direction. If there is a torque in anti-clockwise direction, means there will be the angular acceleration in anti-clockwise direction. If there will be the angular acceleration is what? Rate of change of angular velocity with time, means with time the angular velocity will increase in anti-clockwise direction, and due to increase in that angular velocity, after some time there the condition will be satisfied. Okay, the condition of the pure rolling, v is equal to r omega. Suppose after some time this velocity is also changing and omega is also changing, after some time it is becoming v dash is equal to r omega dash. Okay, you can write it as v dash is equal to r into omega dash. Okay, so write down.
Yes, done, sir. Done, sir.
Okay.
Done, sir.
Okay. On the same concept, we will do one question, then there will be more understanding of it. So here is a disk, and this disk have mass capital M and radius R. This is the point of contact P. And the coefficient of friction between the surface, the coefficient of friction between this surface and this body is mu, coefficient of friction. After some time, suppose after some time, this disk will have some angular velocity of omega. Okay, this disk, oh sorry, initial velocity of this disk is v naught. Initial velocity of the disk is v naught. Final velocity is v, and angular velocity is omega. And this condition is given: omega is equal to v by r. Means after some time the body starts the pure rolling. V is equal to omega is equal to v by r. Okay, this is the condition of pure rolling. We know. Now they are asking what will be the value of this v when the body will start the pure rolling. So we have to find the value of v when body start pure rolling. Okay. So initially this body will have some velocity v naught, and this is moving like this. And here in this direction, in the opposite direction, I told you, in the opposite direction, there will be a friction force. And due to the friction force, there will be a torque in anti-clockwise direction. In this direction, there will be a torque like this. And due to that torque, there will be the angular acceleration. And due to that angular acceleration, there will be the increase of angular velocity. Initial angular velocity of this body is 0. You can see here. But after some time, there will be some angular velocity. Why? Due to torque, due to angular acceleration. And then this condition will be achieved. So now, okay, so this is moving with V naught, having radius R. Now from the yellow color, there will be a solution. This have the radius r. Now in this direction there will be a friction force. In this direction there will be a friction force, and having this have the coefficient of friction as mu, and having the mass m, okay, and radius r. So can anyone tell me what will be the value of this friction force? Coefficient of friction is given. Divyangi? What will be the value of this friction force? Shiva? Okay. So this friction, what is the friction value of the friction force? Because this will be the kinetic friction force, because body is in motion. In motion, what type of friction force is there? Kinetic friction force. So this friction force is what? Normal reaction. Friction force is normal reaction into mu into normal reaction. Okay. Coefficient of friction into normal reaction will be the friction force. So normal reaction will be mg. Okay. Normal reaction will be mg, because mg will be like this and normal reaction will be like this. As there is no motion in the vertical direction, so n equal to mg. Okay. So this normal reaction, so that is why friction force will be mu into m into g. Mu into m into g. So now due to this friction force, there will be a torque. Due to this friction force, there will be a torque, and due to this friction force, we can calculate the acceleration also. Due to this friction force, there will be acceleration, and that acceleration will be this force is acting in this direction. This force is acting in this direction, and this body is having the velocity in this direction. Means there will be the negative acceleration. So you can write F by mass. Acceleration is equal to force by mass. So value of force will be mu mg, and it will be m. M and m will be cancelled out. So acceleration will be minus mu g. Now you can see this mu is constant, g is constant. So this acceleration is constant. So this body will have this much of acceleration. Okay. You will write here. Now, what is the condition after some time? Suppose after some time, this is the condition. After some time, this is the condition. So now, this is the condition. After some time t, the body is having the velocity v, angular velocity omega, and omega is equal to v by r. So we can apply v is equal to u plus at. For this body, we can apply v is equal to u plus at. So what is the initial velocity of this body? Initially, this body is moving with v naught. So initial velocity of this body is v naught. Final velocity is what? V. Because finally this body is moving with v naught, with v. And acceleration is what? Gt or minus gt. And time is t. So we can apply v is equal to u plus at. So v is v, u is v naught, acceleration is minus mu g. Minus mu g. So acceleration is minus mu g into t. So this is suppose equation number 1. And we want to find this value. So to find this value, we have to find the value of time. Now we will see in terms of angular acceleration, angular velocity. What is the initial angular velocity of the body? 0. Because initially this body is moving with linear velocity only. There will be no angular velocity. Final angular velocity of the body is omega. After some time, final velocity of the body is omega. Now, what is the torque of the body? Torque on the body will be this force into this radius, F into R. You can say R into F. Okay, so it will be R, and what is this? Is not mu, this is R. Okay, small r, capital R. Capital R into F is mu into M into G. Okay, the torque is this. Torque can be given by I into alpha. So I alpha is equal to R into mu into M into G. Now, what is the moment of inertia of, suppose this is a disk. This is a disk, na? So for disk, the moment of inertia about the center of mass is mr square by 2. So I is mr square divided by 2 into alpha is equal to R into mu into M into G. So this M and M will be cancelled out. This R will be cancelled out. So alpha you have 2, it will be 2 mu G divided by R. Now you have initial velocity, you have final velocity, you have alpha. You can apply omega final is equal to omega initial plus alpha t. So omega final is omega, omega initial is 0, alpha is 2 mu G divided by R into t. Now from here you can calculate t. So t will be R omega divided by 2 mu G. Okay, now R omega is what? Value of R omega. V is equal to R omega. V is equal to R omega. Okay. So in terms of R omega, you can put V 2 mu G. Now put the value of T in equation number 1. So from equation 1, that will be V is equal to V naught minus mu G into T. So it will be V is equal to V naught minus mu G. Time is V divided by 2 mu G. So now you can see this mu G and mu G will be cancelled out. So it will be V is equal to V naught minus V. So it will be 2V by V naught. So what is the value of V? V is equal to V naught by 2. This is the final answer. Understanding? Hiba and Divyangi, understanding or not?
Yes.
Okay, so write down. a minute. It will be V by 2. This mu g and mu g will be cancelled out, so this will be V by 2, na?